If you remember from last time, we used to go and reduce series parallel circuits. We reduce the resistors so that we can have a more simpler circuit to solve and know how to basically find the equivalent resistance, the total resistance of the circuit. If you have two in parallel, we have a specific way of doing it, and if we have two in series, we have a specific way of doing it. So let's start with that. So the total resistance of the circuit as seen from terminals A and B. So the terminals A and B basically meaning the voltage, from where the voltage is. Bad, again, the only thing that will require reduction here is going to be this first circuit, which is the two in parallel. How do we know that they are in parallel? They are connected at two different separate nodes, all right? So because they are connected at two different nodes, we are going to simplify them. The way to do that is, so we know that parallel, which is R1 and R3 and R2, are in parallel, all right? So the equation is the equivalent, I'll call it R23, is going to be R2 times R3 over R2 plus R3. This is just the equation. So it's equal to R2 is 16, R3 is 47, divided by R2 times, plus R3, okay? Plus R3, which is 47. We put that in the calculator, and R23 will be equal to 16 times 47 divided by 16 plus 47. We get 11.94 ohms, okay? Now that we got the equivalent resistance, we could just replace it now here in the circuit. And it will look something like this. So we're going to remove these two. All right. And between the same two nodes, now we can have a resistor, which will connect to the rest in series. Okay. So with the value, this is R23. So this is R23, which is equal to 11.94 ohms. Okay. We did a lot of this last time. You guys should know already why this is the case. Now we are going to just equate, they are all in series in this case, R1 and R23 and R4. So we can just say that R equivalent now is going to be equal to R1 plus R23 plus R4, which is going to simply just be equal to 15 plus 11.94 plus 9.2. So R equivalent is equal to 15 plus 11.94 plus 9.2, which is 36.14 ohms. Insane. So now we have simplified the entire circuit so that the equivalent resistance, if we want to draw it again, is going to look something like this. So we have our battery, and then we just have one resistor over here. This is plus minus 190 volts. And we have the equivalent resistor here, R equivalent, which is equal to 36.14 ohms. So we solved the first question, part A, which says what will be the total resistance of the circuit. This is what the total resistance of the circuit will be. Now, let's go to the next question. What is the total current supplied? So total current, now that we have our total circuit, or the total equivalent resistance, we can find our total current very simply by just saying the current will always be leaving from the plus side of this is our I. It will always be leaving from the positive side of the battery. So it's going to be in this direction. And we will talk more about directions later. But in this case, in this simple case, we know that we have a current that will be flowing. And we know from Ohm's law that V is equal to I times R. In this case, R is going to be R equivalent because we're looking at I total, IT, all right? So we're going to name this just IT so that there will be no confusion later on. This is I total or IT. So the voltage we know is 100, or before that, let's rearrange the equation. We need to find IT. So IT is equal to the voltage divided by our equivalent. In other words, it's equal to 190 volts divided by 36.14 ohms. And this is going to be our I total. So IT is equal to 190 divided by 36.14, which will be 5.26 amperes. All right. Depends on the question. So here, let's look at the question. The question says, so the question was she's asking is, when do we take answer as it is and when do we multiply by 10 to the minus 3? Here, the question says in amps, not in milliamps, in amps. So we just leave it in amperes. If it was asking in milliamperes, that's when we will multiply by 10 to the power of 3, not minus 3. If we find the solution in milliamperes for some reason and we want to convert it to ampere, then we multiply by the 10 to the power of minus 3. Again, we will cover this conversion a lot last session, so you can refer back to it. And we have finished now part B, which is the total current. Now we need to find the current flowing through the first resistor R1. So I'm just gonna copy paste this circuit again down so we can look at it as a whole. So we have the circuit. All right. We already finished the reduction. Let me just remove the highlight over here and over here. So this is our circuit, all right? So now we are looking at resistor 1, R1, which is this resistor. We want to know the current that is flowing through it. Let's analyze the circuit as a whole now. We know that we have a current here. We have this current here, which is I total, right? This is I total that we just found earlier. And it is going through all of this. Remember that current does not change when it goes through a component, which in this case is a resistor. It will only change when the wires change. So in this case here, we are going to have the current changing. All right. We will call this current I2. And we have the current changing as well when it goes down here. Again, we will call this current I3. Okay. And then again, they're combined back and it's going to be the same current, which is the total current that we found earlier, which will go back to the battery. All right. So this is how current usually flows through a circuit. It flows through components normally, but when the lines are being changed, the current itself is going to change as well. Now, we are looking at 15 ohms. Just check something. Yeah, okay. So we are going through the 15 ohms, sorry. The orange I total is going through it normally. There is no separation of the wire. So simply IR1 is going to be equal to IT, which is equal to 5.26 amperes. ليش؟ لأن the current that is flowing into it زين is the same current that is flowing throughout the entire circuit other than where the separation is happening. So the current through R1, and also we can notice that the current through R4 is also going to be equal to IT. So IR4 is also equal to I total, which is equal to 5.26 amperes. All right. So this is how we can find the currents here and here. Now, let's solve question by question. So that's the current flowing through R1. We have found that. This is done. The currents are done. So part D says the voltage drop across the resistor. Now let's analyze the voltage of the circuit. So earlier we analyzed the current, how the current flows. Okay. Now let us analyze the voltage. So first things first, again, we will consider this to be our ground, okay? We'll consider this to be ground. Remember last time when I said ground, what does ground mean? It means voltage at this point is equal to 0. All right, this is what ground is. Ground is just a reference point, okay? Don't let that confuse you. الحين, the voltage over here that is going through this wire all the way up to the component, this voltage is 190 volts. Why? Because earlier, remember last session, we were explaining how when we have a 0 node over here on the right side, that means this is going to be 190 because the voltage that is being provided by the battery is going to be 190 over here minus whatever is over here. And this is 0. So it is going to be just simply 190 volts. And we know how the current is flowing. We know the current is flowing in this direction. So the polarity of the current, depending on where the current direction flow is, we're going to write the polarity of each resistor. So this is going to be plus, where the current is going through, and then the other side is going to be minus. This is always the case for any situation, any current. The polarity will always be positive where the current is flowing into, and it will be negative. This is always going to be a situation for any resistor or any component, not for a battery source, but for a resistor. And then, so we saw the voltage here is going to be, the purple is 190 volts. Now, we have this other voltage over here, this line, going into these two components. We'll name this voltage 2, which we do not have the value for. So this voltage 2 is going through the lines. Remember, in parallel, voltage does not get affected by the lines. It gets affected by the components that are connected to it. فهني بيكون عندنا a different voltage. All right? So let's call this V1. All right, the purple line is V1, which is 190 volts, which we know. Red line is V2. Now we have another line. Let's give it a green line over here. All right. This is also another voltage going to the next component, which is V3. Okay, which we also don't have the value of. And then we have the last line, which is this line, where we already know the voltage of because we have grounded it. So this is V0, which is equal to 0. All right. This orange line is V0. Now we have analyzed our entire circuit here in terms of current and here in terms of voltage. All right. Now we need to find the voltage across the resistor 1. The way we are going to do that is, there are a lot of different methods, but the way I am going to do that, before that, هل دوم polarity عكس current? Yes, for resistors, every time it is going to be against the current. And you will see that later on when we're assuming the direction of current and doing Maxwell loop and all of that. You will see what I mean by that. The directions will be even more clear. Now, we want to find the voltage across R1, the voltage drop across R1. Very simply, what can we do? We have the resistance. Okay, we have the current, we know the current, and we have the resistance R1. So we could simply just apply V is equal to the voltage of R1, let's say, is equal to I1 R1. In this case, I1 is the same as I total. We already figured that out from the previous example. And we have the value for the resistance. So we can simply just find it by plugging in the values. So it's going to be 5.26 amp times 15 ohms. All right. So VR1 is going to be equal to, just put this in the calculator, times 15. It is 78.86 volts. All right. So we know that this is the voltage drop across resistor 1. Remember, this is not V1. This is not V2. This is the voltage dropping going from the plus to the minus across of R1. لأن هني we are trying to find the voltage drop. It even mentions it. We're finding the voltage drop across. always the resistor is going to drop a voltage. Yani when current is going through a resistor, the voltage is always going to drop from it. This is why we're always going from plus to minus when current is flowing through a resistor. Then there is going to be a voltage drop through that resistor. Before solving the next question, remember from last session what I said. So this is the voltage drop. The voltage drop R1 is equal to the voltage at the plus minus the voltage at the minus. So what's the voltage we have in the plus side here? It is V1. All right, V1. So this is V1, the purple line, minus the voltage at V2, which is the voltage at the minus of this resistor. This is going to be equal to the voltage drop. This is how you find the voltage drop. It is the same idea if I want to compare this to a mechanical thing. If you have a building, then have a building at a specific height. Then we have the height, let's say the height of this floor, the top floor, and then we have the height given here. Let me just write it without drawing this. We have here H is equal to 20 meters. And then we have the height of, let's say, the fifth floor or the third floor or the second floor over here. H is equal to 5 meters. And then, so this is our H1 and this is our H2. Okay, so when we're talking about a voltage drop, we are talking about what is being dropped in between, yani the resistance where it's causing the drop. So in terms of height, it is how much you have to fall until you reach H5. So this is our distance X, or our distance X, let's put it in green, X. So how can we calculate the distance X? We would be doing X is equal to H1 minus H2, because this is how much it will drop in this height. This is the exact same concept in electricity. When we have resistance, it is dropping the voltage. فالvoltage يبقى ينزل من الطابق الأخير لفوق يبقى ينزل للطابق الثالث أو الخامس or whatever. زين? So it is dropping. A hell drop, the number of it is going to be your VR1, which is equal to the difference between the higher voltage towards the lower voltage, which is the positive side, towards the negative side. Okay? هذه هو drop. This is what we mean by drop. X here is what we call the drop. فهني this VR1 is also known as the drop. Okay? And this is applied to any other component. This is the exact same idea that will be applied. For now, what can we figure out? احنا عندنا voltage drop. We already found it here. زين. And we have V1. Now we can find the voltage V2 using this equation. So if we rearrange this equation, V2 is going to be equal to V1 minus the voltage drop, which is VR1. Okay? Which is equal to V1 is 190 volts minus 78.86 volts. So V2 is going to be equal to, just put that in the calculator, 190 minus 78.86, 111.14 volts. Tamam? So this is going to be our V2 value. So we found this to be 111. All right, 0.14 volts. We found our V2 now. Insane. The same concept can be applied again for R4 over here on this side, so we can find V3. Then we do not have the direct voltage drop across of these R2 and R3 yet, but we know that the current هني, it's the same current law. We already found it. We found that current IR4 is 5.26. So we can use V equal IR to determine the voltage that is dropping across R4. يعني, if we want to find VR4, then let me just copy paste this down again. If we want to find VR4, we can do that. How? Here we know that this is I total, the same I, and then and this is also I total. So we know that VR4 is going to equal to I total times the resistance R4. Because we know I total is equal to the current I4 as well. So VR4 will be equal to I total, شنو I total or I4 that we found earlier, 5.26 times 9.2 ohms. We already have the resistance. So VR4 is equal to 5.26 times 9.2. And then the reason I am going into details here is because all of this information you are going to have to know, because we're going to use the exact same thing later on in KVL and in Maxwell as well. It's the exact same concept, but it will be a simpler way of solving. Then, now, 5.26 times 9.2, this is going to give us 48.39 volts. Okay, so this again is the voltage drop of R4, which is plus minus, because this is where the current is entering. So the current is always dropping when it goes through a component. All right. Now, حصلنا احنا الفولتج drop VR4. We also know that VR4 is going to be equal to the whatever voltage on the plus side. In this case, it's V3. And then V3 minus whatever voltage is on the right side, on the negative side in this case, which is V0. And we know that V0 is equal to 0. لأن احنا we decided where the ground is. Okay, it's equal to V0. The way usually you would decide where the ground is, you most of the time, if you have one voltage source, you are going to connect it to the negative of that voltage source. That line is going to be your ground voltage. All right. So we simply know that VR4 is going to be equal to V3, which is going to be equal to 48.39 volts, which we found already from here. And then, so now we have found V3, which is equal to how much? 48.39 volts. And that's it. And we have solved for every voltage around this whole circuit. We know the voltage across each point. Now we can find the voltage across 16 ohm and the 47 ohm resistor using the same exact concept. I'm just going to copy paste this down here again. And then, so remember voltage drop. Let's look at VR2 now. VR2, the voltage drop of it, this is VR2 over here. This is the plus, this is the minus. And then, same thing at the bottom, VR3, this is the minus, and this is the plus. ليش؟ لأن the current here is going like this, and the current at the bottom, it's going like this. All right. Remember, this is a red and a purple current because they are different currents. If we remember from earlier on, we have the top I2 and the bottom I3. Okay. The currents here are not the same as the I total current. So we cannot simply just do IR and find the solution. However, we have a second equation now that we learned عشان نستخدم الفولتج drop اللي هو شنو؟ The plus side, in this case, it's V2 minus the minus side, which is V3. And now we can directly find out that VR2 is equal to 111.14 minus 48.39 volts. So it's equal to 111.14 minus 48.39. 62.75 volts. This is the voltage drop. This is the drop. Okay, voltage drop. And then across R2. If you notice R3, it has the same plus and the same minus as well. The plus is V2 and the minus is V3. This makes sense because these are connected in parallel. And if you remember from parallel circuits, basic parallel circuits, the voltage across will be the same. If we go back to week 3, I think it was, when we are looking at, or was it week 4? Week 4? No, it was week 3. When we are looking at a circuit, yes, it was here, week 3. When we are looking at a parallel circuit, the voltage is going to be the same, up and down. The voltage before is going to be the same as the voltage after because they are connected in parallel. So بالمنطق يعني it makes sense that the voltage drop across R3 is equal to the voltage drop across R2. So we can also say directly that VR3 is equal to VR2, which is equal to 62.75 volts. And obviously you can check as well. You can see that V2 minus V3 is going to be equal to the voltage drop of VR3. So we found all the voltage drops now. We have gotten every single voltage and at any point around the circuit and across every component in the circuit. Now, what is remaining? We need to find the currents. So let me copy this one last time and let me clear as many lines as I can now. Or actually, let me not copy paste this one. Let's copy paste this, the current one that we have here. زين. خلصنا الحين احنا من voltages. Now we are looking at current. We have every single voltage we want. We can refer back to any voltage that we want. And then the current I2 that we still need to find over here. And we have the current I3 at the bottom here that we need to find. Current I2 and then is going through the R2 resistor. So we can write the equation basic Ohm's law VR2 is equal to I2 times R2. صح ولا لا? We have the current, we have the voltage drop. We have the resistance value. All we need to find now is the current. So we can say I2 is equal to VR2 divided by R2. VR2 حصلناه 62.75 volts over R2 is 16 ohms. زين. I2 is simply going to be equal to, put that in the calculator, 62.75 divided by 16, which is 3.92 amperes. زين. We found our I2. Now we will do the exact same thing again for I3. All right. I3 is equal to, again, it's going to be equal to VR3 divided by R3, just Ohm's law, basic Ohm's law. And we have found R3 earlier, which is 62.75 volts divided by, now the resistance is different. The resistance is 47. So I3 is going to be equal to 62.75 divided by 47. We have 1.3334 amperes. زين. And we found now the currents through everything and the voltages through everything. We can solve any question they might ask us about this circuit. يمدي نستعمل current divider. Yes, you can use the current divider rule, but I don't want to explain that yet لأن people get very confused when I talk about current divider or voltage divider. I will leave that to the very end inshallah after I explain the basic concepts. هذه الأجوبة بيطلع نفس فكرتها لو سوينا جراف لأن شفت بعض الجرافات بشكل مربعات أو شيء كذي. It is the same idea when you do a graph تقريبا. Yes, it is the same idea. But again, I don't want to overcomplicate. I want to simplify. الحين, yes, we have solved for everything, but I want to explain one more point. زين. Let me just take this part of the circuit and enhance it. زين. I don't want you guys to look at anything except the current now. زين. انسوا كل هذا. زين. انسوا كل هذا. لا, I3 نبغى. We want the current. Well, this forget about this, forget about this. We just know that there is a resistor and that's all we need to know. هني عندنا I2 وعندنا I3 وهني عندنا I total. If you notice, I total is split into half here. If we draw it, current is going like this, زين, and بعدين it is going like that, and it is going like this, زين. هني there is flow, and flow. معناته I total is being split into two parts. معناته I total, زين, it has to be equal to I2, or I2 is in red, I2 plus I3. زين. ليش؟ لأن here we have a junction, we have a point. any current going in has to equal all the current that is going out. زين نفس الفكرة on the right side. Any current going in has to equal all the current that is leaving. So we know that I2 plus I3 has to be equal to IT. So we can check this now. نعرف IT كم? We know that IT is 5.26 amperes. We know that this is 5.26 amperes. So it has to be equal to, we know that I2 was 3.92 plus, we found I3 to be 1.34. We put this in the calculator just to make sure. And you notice that this is correct. This whole phrase over here is, or this expression or this equation is correct. So this is the whole concept of basic circuits. This is the whole thing about voltage. يعني إذا فهمتوا everything I just explained now, nothing in the future should be difficult. أهم شيء polarity you understood. And when we have a polarity, that means we have a voltage drop going from plus to minus depending on the direction of current. And then you understand in the lines are voltage unless they hit a component, but current can go through a component without changing. The current will only change if there are different lines. يعني you go into a parallel circuit type of structure. That's when current will change. And that's pretty much it for the entire question. يعني if we look at the rest of the questions, what are they asking? Find the voltage drop across R1, find the current flowing through R2. عندنا كل الcurrents, voltage drop we have, current we have, voltage drop, current, voltage drop across everything. We found everything and we have completed. Now I'm going to add an extra question to this. What about power? الحين, what if I tell you I want the power of the entire power, remember, is simply just I times V. And I want the power across the entire circuit. We can go and use the very first circuit that we found here, this one, and then to find the power across the entire circuit. If we want the power يعني supplied by the entire circuit, we know that I now is equal to 5.26. So power is simply going to be 5.26 times 190. This is all the power supplied then by source, by the power source اللي هو ال 190 volt source. Then this is a power source or a voltage source. It is providing the current and the voltage across everything. So this is going to be the power across everything, 5.26 times 190. However, let's say I want to know how much power is being consumed by the R2 resistor over here. Again, same thing. We are just going to put PR2 is equal to IR2 times VR2. And that's it. And then we solve. We know that IR2, we found it to be 3.92, which is the one in red. 3.92 times VR2, we found it earlier. It's the voltage drop across the second resistor, which is 62.75. And that's it. Clear? So this is how you can even find the power across the circuit. Before I move on to KVL, then the KVL is going to be concepts based on this as well. Anyone has any questions, you can ask now. Any specific questions about anything I have done here. Make sure you understand that these lines are voltage lines, and then make sure you know the difference between voltage drop and the voltage at a point. يعني هني voltage at this point is different than the voltage across R1 or the voltage dropping into R1. Make sure you know how to calculate voltage drop. It's plus minus the voltage at the positive side minus the voltage at the negative side. Make sure you know that current can flow freely through from the positive end, and when it ends from the positive end of a source, okay, so current has to leave the positive end of a source, and then it will go into a component like a resistor, and the polarity will be plus towards where the current is. And that's pretty much it. And then you just apply Ohm's law for everything else to find it. Yani if you see the math, there's nothing complicated. Everything is V equal IR, or V is V1 minus V0, or V high minus V low, V plus minus V minus. That's it. Basic simple math. فرق voltage شو قصدك يعني؟ divider rule, voltage divider. إذا ما قدرنا نسوي V equal IR. ما هذا in this case here we couldn't do V equals IR. So I analyzed it in a different way. I found the plus and minus method. إنه أشوف إن the left side and the right side to find the شو اسمه. Yeah, exactly. VH minus V. Exactly. اللي هو الفولتج دروب اللي هنا نفس same as V2 minus V3. If you notice that you cannot find V equal IR, you have to find a different method to do it. Either you have to reduce the circuit, or you're gonna have to simplify it in a different way, or you can find the voltages like I did. في a lot of different methods. But here you have to make sure you understand the concept here. زين? You want us to start KVL? I will use the same exact circuit again to explain KVL. So this is going to be EE week 4, 5 وصلنا week 5. زين. Let's take the exact same circuit again in its simplest form. Where was it? Let's take the circuit so we can explain KVL. Actually, I want this circuit. Yes, KVL. What does KVL stand for? KVL في كان عالم اسمه Kirchhoff. Everyone hates him now because of this rule. Kirchhoff's voltage law. زين? That's what KVL stands for. What does KVL stand for? KVL stands for Kirchhoff's voltage law, but what does it mean? I mean, what does it represent? Allah يخص بليس Kirchhoff. What does it represent? It represents what he wants to say is that the voltage across the entire circuit must eventually be equal to 0. بما معناه. إنزين بما معناه. Let me just redraw this a little bit better. إنزين. So we had one more resistor over here. And it was the resistance of it. مو مهم. We're just going to name it R2. I don't know why I wrote 3. R3. بنغير الأرقام شوي ما فيها شيء. R1, R2, and R3. إنزين. What do you notice about the circuit? It is a series circuit. KVL is firstly only applied on series circuit. All right, a circuit in series. You cannot use KVL for a parallel circuit. In that case, you'll use KCL, which you guys, I didn't see it on Moodle, so we're not even going to go over. Then later on, mesh law is going to just, and nodal law is going to just basically do the exact same thing. So let's give this 10 ohms, and let's give this 20 ohms. Then, but we have a voltage here. Remember, this is a series circuit. So again, if we draw our lines for the voltage, and then this is our V1, which we know is going to be equal to 190 volts because we are going to assume that this line is the ground. Then this line is the ground. So V0 is equal to 0. All right, ground voltage. بعدين بيبقى لنا هني line. We'll call this V1. And then another line over here. We'll call this V2. And then I want you guys to tell me here, what can we say about is the current that is going through here and the current that is going to go through the entire circuit? What can we say about it? The current, what can we say about the current? شو عنا? No idea, شكلكم ضيعتوا. What I want to say is the current here is going to be the same. Yes, exactly. It's going to be the same across the entire circuit. All right. The current is not going to change throughout the entire circuit. This current I is equal across everything because this is a fully series circuit. So there's no lines going left and right. معناته the current is going to be the same throughout everything. So we can find that current directly by what did we do earlier? By doing reduction. However, in KVL, what does KVL say? KVL, like I said earlier, he says the sum of all the voltages has to be equal to 0. بما معناه إن if we start from V1 over here, from the positive end, from this plus, and then this is plus minus, plus minus. If we start from the plus and then reach to this minus, the voltage drop should be then all completely back to 0. يعني we are starting from 190, the voltage will drop until it reaches 0. That is what they mean by that. So how are we going to do this in practice? Remember when I said current is flowing, so this is all going to be plus on one side, and it's all going to be minus on the other side. Wherever the current is entering, that is going to be your positive side. All right? So we have our first voltage, which is, let me call this actually V2 and V3, because I called this V1, this is V2, and this is V3. And then, so we have our first voltage, and then our first voltage is the V190. We are going to look at the voltage going from here to here, which is the 190 volts, okay? Let's call it VT, which is the V source, all right? VT, here there are two main rules you need to know. If current, before I even explain all of this will also help you in the Maxwell later on. إذا عندنا a battery, okay? Yeah. زين بعدين عندنا resistor. All right. So when current is going through a battery, let's say the current direction is this way, in this case, زين. Actually, we'll do it the same direction for all of the cases. So let me just reverse this. When current is going through a battery, we know that this is the largest side is the plus side and the smaller side is the minus side. صح? So we have a current I going through this voltage source. If it is going from the plus to the minus of the battery, that means we have a voltage drop, or this is absorbing voltage. It is not giving voltage. So it's going to be a minus V when it comes to the terms of calculation. So it will be negative, all right? In this case, if we have a current going like this, where this is plus and this is minus, okay? So it's going from the minus to the plus of the battery. معناته هني we have a positive voltage. This is a plus V. تمام? And lastly, when we have a resistor, when current is going through a resistor, we will define the polarity of the resistor in the direction of the current. And we always say voltage drop. احنا يوم نقول resistor, there is always a voltage drop. So there is always going to be a negative because the voltage is dropping. So we say voltage drop. تمام? That's why we call it a voltage drop. لأن drop is, it's going lower. The voltage is becoming less and less. تمام? طبعا this is, I'm talking about the case when we are trying to do the mesh analysis and the KVL analysis now, which you will see why. So this is minus V. When it's in the battery form, minus and plus, it's going from the minus to the plus inside the battery, it is positive. When it's going from plus to minus, it is negative. The current in all cases is going in the same direction here, okay? Now we can go back to this circuit. Now we can go back to this circuit and understand how to solve. So, the voltage of the battery, V total, it is in which direction? The current is going through it from minus to plus. Minus to plus, that means we have a positive voltage. Then we go to the next component. The voltage of R1, let's call this VR1, زين. And this is VR2. Then VR3, the voltage drops. VR1 is a voltage drop. It's a resistor and it's going from plus to minus. It's a voltage drop. فمعناته it is minus VR1. VR2, same thing. It's going from plus to minus. It is minus VR2. Then don't get confused by V3 and V1 over here. We're not going to use these in the case of KVL. That was just to explain a concept. Continuing, again, we are looking now at VR3 اللي هني. Current is going through here. Current is going through here and exiting the other way. Okay, so it is another voltage drop. Again, this will be minus VR3. And then we reached back to our source. خلاص ردينا للبداية. So this will all be equal to 0. This is KVL. This is exactly what they mean by KVL. You go step by step through each source and component and look at the current direction. We can assume the current direction, that is fine. إذا كان الاسsumption مالنا غلط, الvalue مال الcurrent مالنا بيطلع negative, and you will see that now. Now we can apply Ohm's law. زين. Before that, VT, what's VT? 190 volts, صح? 190 volts plus. We already know the voltage of the battery of the source, so we can just write 190 volts. Minus, remember Ohm's law? What's Ohm's law? V is equal to IR. So we can write minus I R1 minus I R2 minus I R3. Then let me move this a bit to the left. Minus R3 will all equal to 0. So IR1, IR2, IR3. This is just V equals IR. We know that VR1 is going to be equal to IR1. يعني هني زين إذا كتبنا VR1 is equal to IR1 لأن I is the same throughout the entire circuit. It's passing every component. زين. VR1 is exactly the same as the voltage drop across R1. VR1 here, this is all of these are voltage drops. تمام. أنا usually عشان أنا I don't get confused when I'm writing a voltage drop I write R after it. I don't write just V1. أنا بكتب VR1 إن الvoltage drop across R1. If I just write V1, that's what I mean. What I mean by that is just a voltage at a specific point. تمام. For VR1 is the same as the voltage drop across R1. This is exactly what it is. This VR1 is the voltage drop across R1. This VR1 is the voltage drop across R1. That's why we are putting a negative sign, because it's a voltage drop. And we can continue. We have the values for R1, R2, and R3 minus I times R1, which is 15, minus R2 is 10, and minus R3 is 20, is equal to 0. الحين عندنا equation where we only have current that is unknown and we can find the current. So let's group everything up and solve this equation. 190 volt, we'll take it to the other side. Then, so it will become it's going to become I. Let's add them up. Minus 15, minus 10, minus 20 is going to be minus 15, minus 30, minus 45. I then is equal to, this is just algebra. I'm just grouping all of this up. Is going to be equal to minus 190 volts. We can cancel the minus because we have minus on both sides. I is going to be 190 over 45, which is going to be equal to 4.22 infinitely going, and then 4.22 amperes. And this is how you apply KVL to find the voltage across a series circuit. This only works for a series circuit only. لأن when you have a parallel circuit like the case here, when you have two parallels, the current is not constant in between them. The current is going to change. So you cannot apply KVL here. متى تقدرون تطبقون KVL هني if you do reduction for this. يعني إذا سويتوا له reduction and you got the R23 over here you can do KVL directly. All right. So this is the concept of KVL. Very straightforward, very simple. خلنا نشوف الأسئلة. إنزين. Remember when I mentioned V1, V2, V3? إنزين. Now let's actually find those V1s and V2s and V3s. Let me copy paste this now. إنزين. Now let us find V1, V2 and V3. Okay. نعرف إن VR1, we know that VR1 is equal to I R1. والحين طلعنا ال I. فنقدر نعوض 4.22 times times كم 15. و VR2 is equal to IR2, which is equal to 4.22 times 10, and VR3 is equal to IR3, which is 4.22 times 20. These are the voltage drops. Again, when I put VR معناته voltage drop. ف VR1 زين is going to be equal to لا كان زين صغرت هذا شوي دقيقة. Let me just make it a bit smaller. So IR1 which is equal to 4.22 times 15. It's equal to, which is equal to, let's find each one. 4.22 times 15 is equal to 63.3, sorry. And then this is voltage. The voltage drop across VR2, the second resistance is 42.2 volts. And the voltage drop across VR3 is 84.4 volts. If you notice something, كل ما كبر الريزيستنس انزين كل ما كبر الفولتج دروب. The more your resistance you have, the more the voltage drop is going to be, the higher the voltage drop is going to be, which makes sense. يعني كل ما انتم ترفعون على البناية كل ما الدروب بيكون اكثر للطابق الارضي او الطابق الاول. The same idea هني. فكل مرة الريزيستنس ارتفع كل مرة the higher the voltage drop will be. Now let us find V2 and V3. How can we do that? We know that VR1 is here. And then between the plus and minus. So VR1 is equal to V1 minus V2. All right. So we could just rearrange. V2 is going to be equal to V1 minus VR1. يعني بما معناه it's equal to, what is V1? V1 is 190 volts. Minus VR1 طلعناه كم؟ 63.3 volts. So it's equal to 190 minus 63.3 volts, which is 126.7 volts. فمعناته هني we have 126.7 volts at this point, at this line in between R1 and R2. The voltage here between R1 and R2 is 126.7 after the voltage drop. And then what about V3? I want someone to give me the answer directly for V3. What is the voltage drop V3? Instantly لازم الحين حد يعطيني الجواب. If you understand the concept, you should instantly look at the circuit and know what V3 is. عاد مو أسهل من كذي قاعد أسوي لكم إياه and I'm circling it. ليش تسوي V2 minus VR2? ليش تتعب روحك؟ You know that V3 is connected to the ground after it هني لا؟ So V3 VR3 لو تطالعونه VR3 is equal to V3 minus V0 minus the ground. V0 is equal to 0. For V3, VR3, the voltage drop has to be equal to V3, so it's equal to 84.4 volts. ليش تروح تتعب روحك تسوي minus وكل هذا؟ So this is going to be 84.4 volts. Why? Conceptually, why is this the case? لأن الحين احنا وصلنا لهالبوينت صح؟ عندنا 84.4 volts. هني يوم بيسوي دروب بيوصلنا للزيرو فولت. فلازم الدروب هني الفاينل دروب يساوي الفاينل فولتج that we have here. يعني لو قاعدين ناخذ الاكزامبل مال البنايه زين احنا في النهايه نبغى نوصل للطابق الارضي. اوكي وصلنا لين هني. انا اقول لك هني بيكون الطيحه مالتك 10 متر زين. فانا الحين بسالك انت ارتفاعك اي ارتفاع؟ سيده بتقول لي 10 متر لان لو طحت بطيح انا 10 متر عشان اوصل للصفر. The same exact idea. هني we know that the voltage is dropping at 84.4 يعني بيستوي minus 84.4 وبيوصل للزيرو. صح ولا لا؟ We already know that directly. So لازم هني الفولتج ماله يساوي الفولتج دروب اللي بيكون هني. Okay? This is the whole concept. And if you check, if you do 126.7 اللي هو V2 minus V3, you are going to get VR2. Let me just do it on the calculator. 126.7 minus 84.4, it is going to be equal to 42.3 يعني, which is 42.2 volts. Rounding errors will happen a lot in electrical, so that's fine completely. All right? This is the whole concept of KVL. Everything that you needed to know and even more. هذا هو ال KVL. خلينا نشوف examples مال KVL. وين راح الصور؟ يعني مثال. Let's see how simple this or difficult or complicated this will be. شو رايكم ناخذ بس 5-minute break عشان أجمع صوتي شوي. Try to solve this yourself لأن this has to be very easy now. زين I want to see you guys be able to solve it. أنا بروح أجيب لي ماي شوي أجمع صوتي من الصبح قاعد أتكلم. In 5 minutes exactly I will be back اللي هو it's going to be at 8:05 8:10 sorry. I will be back. Try solving this equation, this circuit. It's very easy. Apply KVL to find the current in the circuit. Just what we did earlier. The question says find I. So find current I through this circuit. And I'm going to give you a trick already. This is the plus. So there is a current. Keep in mind there are 2 voltage sources. That's the only extra thing. But you know how to deal with voltage sources earlier. If you are going through a voltage source with current, you are going to do plus or minus V. All right. I'm just going to write the values of R1. R1 is 1.9 kilo ohms. R3 is R2 is 3 kilo ohms. هني. R3 is 5 kilo ohms. And R4 is 3.8 kilo ohms. Please try to solve this until I come back. Then voltage 1 is given to be 12 volts. Then this is 12 volts. And voltage 2 is given to be 6 volts. Okay, redraw the circuit completely by yourself and try solving. Remember, we have kilo ohms, you have to change them into ohms as well. We have covered that in the very first session. يوم يكون عندكم كيلو لازم تحولونه لأومز فقط. And I'm giving you the trick. I am giving you the direction of it, which I will explain also how you can figure out later when I come back. Any plus, any minus, any minus, any plus. When you are solving, make sure you are doing your polarities correctly for your resistances as well, and apply KVL. تمام? I'll be back in a few minutes. إنزين. I hope you tried to solve it. Someone said 1.31 amps. I don't know. Let's check. What do we do here? Let's just redraw the circuit in our own way عشان نسهل الموضوع. عندنا a voltage source here. إنزين. عندنا resistor هني. عندنا resistor هني. We have another voltage source over here. Plus minus. And then we have another resistor over here. Oops. And then we have another resistor over here. Okay. The current, we are saying it's flowing in this direction. Okay. This is the flow of current. So we are first thing, we're going to assign polarities. We know that this is plus minus already. We know that this is plus here. And this is minus, minus from the batteries. For the resistors, plus will be where the current is flowing into it, plus where the current is flowing into it, plus where the current is flowing into it. And then, so minus, plus for the resistors. Okay. We have the values now. Let's put in the values for each one. This is 12 volts, 12 volts. This is 1.9 kilo ohms. I'm just going to write 1900 ohms directly. Then 1 kilo ohm is 1000 ohms. So you just multiply by 1000. And هني 3000 ohms. هني عندنا voltage of 6 volts. هني عندنا voltage of a resistance of 5000 ohms. وهني عندنا resistance of 3800 ohms. Okay, 3800 ohms. This is how we draw the circuit. Now let's draw it at the bottom here, copy paste it here عشان we start solving. تمام. So the first step is KVL. What does KVL say? KVL says that all the voltages, we start at one source, whichever source you want. You can start at any point in the circuit, and then you have to make a full loop to come back to that point, and we will put our voltages. So V1, let's call this V1, and let's call this V2. And this will be VR1, this is VR2, this is VR3, and this is VR4. تمام? I think it's the same way. Yes, it's the same way as up as well. بنبدأ من V1. V1 is positive because the current is going in from here out from there. So it's going from minus to plus, so it's going into the positive direction. So it's correct. So what this means is this voltage source is providing current. It's not working against it, the current. It is with the current flow. بعدين we have a voltage drop VR1, which is minus VR1, minus VR2, plus V2, لأن again, if you look at the current, it is going in from the plus and coming out of the minus. Is it actually? It's going in from the plus and coming out of the minus. Is that it? Yes. So it is the opposite. It is not plus. It is going to be minus. This is working against the current. So make sure you put minus V2 in this case. Again, why are we putting minus here? Because it is going into the plus and out of the minus. Just like a resistor, when we are going from plus to minus, it's a voltage drop. So when we're going from plus to minus, this is becoming a voltage drop. And then minus the last resistor, which is VR4. And this has to all come out to 0. نعوض الأرقام الحين and also Ohm's law at the same time. V1 is 12 volts plus 12 volts minus VR1 is I R1. R1 is how much? 1900. زين. Minus R2 is 3000. So IR2 minus 6 volts. لأن this is a negative. This is working against current. And then minus, so this is 6 volts, minus VR4, which is going to be, oh, I forgot about VR3. There is VR3 as well. I forgot about VR3. So we're going to have VR3 and VR4 minus VR3 minus VR4 equals 0. Sorry about that. I forgot about the X resistor here. So minus VR3. Let me just drag this a bit to the left so I have some space. Then 12 volts minus I, okay, VR1, VR2, V2, VR3 is I. V is equal to IR. This is all I'm doing. Times 6 volts, sorry, 5,000 ohms. Minus I times VR4, which is 3,800. And this is all equal to 0. Okay? This is all going to be 0. This is not VR2 twice. This is VR2 and this is V2. This is the voltage V2 هني, the battery, the source. هني VR2, هني V2. They're two different things. This is a voltage supply and that is the voltage drop across R. Two separate things. زين? Now, we can simplify. Let's group up the voltages. So 12 volt minus 6 volt, that's going to be 6 volts. Minus, let's just add these all up. So 1900 minus 1900 minus 3000 minus 5000 minus 3800. You're going to get minus I, or minus 13,700 I is equal to 0. Okay, so this is all equal to 0. So we know that 6 volts, we'll take it to the other side. We're going to get 13,700 I is equal to 6 volts. So I is going to be equal to 6 divided by 13,700, which is going to be 6 divided by that is 4.37, or just 4.3796. Let's just do it up to this much, times 10 to the minus 4 amperes. Okay. Another way we can write this, I don't think they requested the current in any specific unit, but if we want to write this in milliamperes, okay, we are going to write 4.3796 times 10 to the minus 4. And then this is in amperes. We want to change it to milliamperes. We will keep milliamperes up and amperes down. 1 ampere has 1000 milliamperes to it. Or in other words, it's as if we are multiplying by 10 to the power of 3. Okay? So I is equal to, just the answer from your calculator, multiply it by 1000, is going to be 0.437, or 43, if I just round it from here, it's going to be 0.44 milliamperes. And that's how you find the current across everything. Very straightforward, very simple. The question I think actually was asking in milliamps, so this is how you will convert it. It's very direct, very straightforward. You just need to make sure تعرفون الساينز مالكم كيف يكون. لا تخربطون في الساينز. إذا تروحون من بلس لماينس معناته نيجاتيف. إذا قاعدين تروحون من ماينس لبلس يعني you're gaining. So this is a voltage drop when you're going to from plus to minus, and when you're going from minus to plus, it is a voltage gain. تمام? And that is it for this question. We found our final answer. إيه سجاد يابا صح. نور يابا صح. Mariam, I don't know what your mistake was, but I hope you figured out the mistake from this. This is exactly how you would solve it. Very straightforward and very easy. Let me look at the next question. Let's see if it's worth... I'm going to go over this very quickly in theory. سؤال يقول apply KVL and find the voltage across terminal A, B. All right. Let me redraw this for you guys very quickly. عندنا هني plus minus. بعدين عندنا هني another battery. هني ما عندنا ولا resistor. هني all we have are voltage sources. زين عندنا minus plus. This is a good question so that you can practice with your minus and your plus. بعدين عندنا هني minus plus. بعدين it is connected back to this. So the first thing you do is identify the polarity of each one عشان you guys don't get confused. And this is going to be minus, 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 minus. زين. This is plus minus, plus minus, plus minus. And also in the question, in the diagram, they are calling this plus and this minus, and this is VS. And I will explain this in a little bit. فمعطينا V1, V2, V3. V1 معطينا إياه 14 volts. V2 معطينا إياه 8 volts. V3 معطينا إياه 15 volts. And V4 is 17 volts. All right? So how are we going to solve this? Exactly the same way we were solving KVL. We're just going to apply KVL instantly. Let us assume a current direction. It doesn't matter which current direction we assume. However, let us assume the current is going just like this. In this case, I always assume current direction to be going clockwise. Okay, so let's call this I. This is an assumption I am making. I am not sure if it is right or wrong. And then if I get my answer in the negative, I will know I chose the opposite direction. صح? So let us start solving this now. This whole circuit, let us start solving it. So again, the idea is we need to find the voltage VS. Then we need to know what VS is. So now if we just write this, let's start from VS itself. So we're going plus to minus into VS. When we go plus to minus, that is a voltage drop. So it will be minus VS. Okay. We'll move along. Here we're going from minus to plus. So we are getting a voltage gain. So it's plus 14. Bad. We'll move along from plus to minus. So it's a voltage drop. بعدين plus to minus again. So it's also a voltage drop. Minus 15 up here. بعدين minus to plus, it is a voltage gain. And this is all going to be equal to 0. And now we just solve for VS. That's it. That's the whole question. We'll take VS, so minus VS, and then we'll simplify all these numbers. Plus 14, minus 8, minus 15, plus 17. بيطلع لنا plus 8 is equal to 0. So VS is equal to 8, and that's your final answer. That's it. We don't need to find current. We don't have resistance أصلا to find the current, but we just assume a direction for it. Now, إحنا in this case, VS came out as positive. And then, what if we chose the opposite direction? And then, let's just assume that we did the same exact question, but we assumed the opposite direction. The reason I want to do this is I want to explain a concept here for you guys. لأن هني our voltage came out as 8, معناته the polarity we have is correct because we got the correct polarity, so the correct value came out. We assumed the correct polarity because we do not know this VS how it is. If we do it in the opposite way, and then let's say we assumed the polarity was the opposite. Yani we assumed this was the plus and this was the minus. The only thing that will change in our equation is here. It's going to be the exact same equation, but the only thing that will change is VS is no longer negative, and it's going from minus to plus, so it's a gain. So VS will become positive. That's the only change that will happen. This is plus VS. Okay? VS minus 8, or was it plus 8? VS plus 8 is equal to 0. VS will be minus 8 volts. And then this is volts. So we know here that we have a minus. We notice that we have a minus, a negative sign. When we have a negative sign coming out in our solution for a voltage or for a current, we know that the polarity must be in the opposite direction, or the current is in the opposite direction in some cases. تمام? ففي الحالة we know that the plus and minus should have been opposite. So the correct way would be plus and minus, and we will put this as positive 8 volts. What does this mean? معناته there is a voltage dropping here, not a voltage being gained. لأن when we assume there's a voltage gain, we got a negative value. So a gain of a negative value is basically a drop. تمام? This is just a concept I wanted to share. We will go into Maxwell, but I want to solve the last one. الحين the last this question. لأن when I saw it يعني أنا بروحي شوي خفت بعدين شفت how تافه السؤال إيش كثر كان قلت let's solve it. فعندنا this circuit زين لا يخرعكم ولا شيء في هالcircuit. We are going to apply the exact same concepts that we have been applying this entire time. So this is our circuit, okay? This is the circuit that we have. They want us to find two things. They want us to find VCE and VAG. What does this mean? They want us to find the voltage from C to E, and they want us to find the voltage from A to G, okay? The first step is we need to determine the current in each of these circuits. The first step, اللي هو A, B, C, D, and E, F, G, H, okay? So that is the first thing we are going to do. We are going to assume a current direction. Let's assume it this way. Zain, for the first one. And for the second one, let's assume it the opposite way. Now, how do I usually assume my currents? I usually assume my currents based on the voltage source. So إذا هني عندي voltage source, wherever the positive of the voltage source is, I will assume that the current is leaving that voltage source. Always that's how I usually assume it. إنزين? Same thing on the left side. We have a voltage source. I'm assuming the voltage source is leaving this voltage. تمام? In the case where we have only one voltage, obviously, in the loop. Now, to find the current here, we are going to use, again, KVL. The same idea. We want to know the current that is flowing around here, which we will call I1. And we want to know the current that is flowing through here in this direction, which we will call I2. Okay? طبعا, now that we assume the current is in this direction, we have to assume L polarity for each one of these resistors as well as plus, 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 and the voltage is obviously plus here. This is going to be minus, 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 and minus. The same thing for the other side. This is going to be minus, where the current is leaving, minus, minus, because this is how it's going. It's going all the way like that. Then so minus, 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 and this is already minus for the battery. And this is going to be plus, 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 and plus. Okay. Let's put the plus over here. Let me try to select all of this. Copy paste it down here now. بنحاول نكبر الصورة نشوف إذا بتختار وايد ولا لا. Okay, there we go. زين. So this is what we have now. And then our resistors. Let's take the values of the resistors. R1 is 6 ohms. So this is 6 ohms. 6 ohms هني. R2 is 5. Where is R2? This is 5 ohms. Okay, this is 5 ohms. R3 was 9 ohms. And R4 is 5 ohms. R4 is this one, 5 ohms. R6 is, R4 is 5, R5 is 7, and R6 is 8. R5 is 7 ohms, so this is 7, and R6 is 8. Okay, صح? Yes. And now the voltages. We have V1 is 21 volts, so I need 21 volts. V2 is the battery in the middle, which we are going to look at in a bit, which is 11 volts. 11 volts. We didn't draw the plus and minus here. This is going to be plus, minus. إنزين. ليش؟ لأن this is the polarity of a battery, plus and minus. So هني بيكون عندنا 11 volts. And the last one, V3, we have 36 volts. All right. Apply KVL twice for each circuit, left and right, and we will solve. So I'm going to solve this very quickly, بس عشان we get it out of the way. So we have, for the first one, for I1, زين, for I1, عندنا we'll start with this battery. So the current is leaving the battery, so it's going from minus to plus. معناتها it is plus 21 minus I1 6I1 زين اللي هو V equal IR اللي هو VR1. I'm just substituting it directly. Minus 5I1 minus 9I1 is going to be equal to 0. As you notice here, we can instantly find I1. I1 is going to be 21 minus, so minus 6 minus 5 minus 9 is going to be minus 20I1 equal to 0. So I1 is equal to 21 over 20, which is equal to 21 divided by 20, 1.05 amperes. Okay, we found our I1 value. This is our I1 value. Let us do the exact same thing for I2. So now we are looking at I2. Okay, for I2, again, we're going to look at this. We start with the battery and go with the flow of current. فهني 36, it's plus 36, لأن it's minus to plus. Plus to minus, this is going to be minus 8I2 minus 5I2 اللي هو this resistor, وبعدين the last resistor is minus 7I2. زين. All of this should equal to 0 as per KVL's Kirchhoff's voltage law يعني. Now if we simplify this, 36 minus 8 minus 5 minus 7 is equal to minus 20, so minus 20 I2 equal to 0. I2 is going to be equal to 36 divided by 20, which is 9 over 5, which is 1.8 amperes. This is our I2. All right. So we know that the current flowing through here is equal to this much, and we know that the current flowing through here is going to be this much, 1.05. الحين we can start looking at the question. The first thing they want us to find is VCE. زين. Let me copy paste this down one more time here. Let me copy it with all the numbers. And let me shrink it a little bit. So just this much is fine. Okay. So again, we are looking for first VCE. VCE, let's use blue. VCE. معناته we are going to start from C and go to E. This is what VCE means. يعني احنا بنطالع ال VC. Where's point C? This is point C over here. Okay. We are going to follow this path until we reach point E. So this is how we are going to find it. زين. We are going to start from point C and go follow the lines all the way to point E. Okay. Very simple. Actually, it's the opposite. We are going to be going, لأنه we say from VCE معناته it is going to end at C starting from E. It's going to be the opposite. My bad about this. زين. النوtation لأنه is always going to be CE يعني E to C. تمام. It's going to be the opposite لأن معناته we want to find the voltage at C with respect to E. So we have to start from E and arrive at C. So we are going to go in this blue direction هني from E, H, B, C. Okay. And we will apply the same concept that we did for the KVL. But instead here we are going to say the voltage CE is equal to, not 0 is equal to, we are going to say from C to E because this is not a complete loop. So we're just saying the voltage points between C and E is going to be equal to, and then we start. Current is flowing here from plus to minus, so it's a voltage drop of I2 and then times 5. I2 times 5. This is simply just VR4. Saying this is VR4. Okay. Then this is going to be minus. ليش it's minus؟ لأن it is a voltage drop. We finish from this. What is the next thing we have? We have a battery. Where is the minus? It's going from minus to plus, so it is going to be a positive number. So plus this battery in between, which is 11 volts. Okay. And then we are going from B to C now. آخر component عندنا هني. This is from plus to minus, so it is again a voltage drop. So this is minus minus I1, لأن now we are dealing with the current I1 times 5. This is what VCE will be equal to. طبعا احنا we already have I2 and I1 that we found from earlier on. So VCE is going to be equal to minus I2 times 5, which is 1.05 times 5. Okay. Plus 11 volts. Minus, again, oops, this was supposed to be in green. This is not the, oops, one second. بدل ما أرد أكتب كل شيء. This is the second part. هذا بيروح هني. This is the purple part, the purple circuit. The green circuit is minus I2, which is 1.8 times 5 plus 11 volts minus 1.05 times 5. تمام? This is, and then we're just going to put this in a calculator and calculate. And VCE is going to be equal to minus 1.8 times 5 plus 11 minus 1.05 times 5. And we are going to get a negative value, which is fine. It's going to be minus 3.25. زين هذا معناته VEC is going to be plus 3.25. It is just opposite in direction and opposite in value. بس احنا we want to find VCE. So this is going to be the voltage from E to C. زين a voltage at C with respect to E. تمام? Is this clear what I did? So yeah, like I said earlier, when we write CE, this means we are going to go to C starting from E. This is what the notation means. All right. السؤال كان اللي بعده find VAG. يعني we will start from A and go all the way to G. زين. So we're going to start moving in the direction of the current like this, and we're going to do the exact same thing again. Same concept, nothing is different. So VAG. VAG. Then it's starting from G and then we reach A. Okay. Starting from G going to A. Look, for this one, I want to explain something عشان بس ما تخربطون. Let me bring this down. زين. الحين خلصنا احنا من blue part. We're not looking at that anymore. We are looking at the orange part. We're starting from G and going to A. From G over here and we're going to A. You can choose any path. تقدرون you go the longer path يعني from around here. And then you can go like this if you want. عادي, there is nothing wrong with that. بس ليش تتعبون روحكم? You guys, any way you do it, you're going to find the exact same answer. So you can just go directly to the shortest path, which is like this. And then like that. And then over here straight to A. And you will see what you are going through. And then you will solve. So VAG is going to be equal to, going from G to H, it is, if you notice here, we are going against the current. We are going from minus to plus. زين معناته we are getting a voltage gain. We are not getting a voltage drop here. We are going from minus to plus. So the 7 over here, it's going to be I2. What was I2 again? I2 is 1.8. So it's going to be 1.8 times this is going to be plus 1.8 times 7 ohms. ليش؟ لأن again we are looking at the polarity. We're going from minus to plus this time. We're not going from plus to minus. إنزين? So we are going to put a plus value here. Moving on, minus to plus again. So this is going to be plus 11. And then again here, again we are going from minus to plus. For minus to plus معناته we are adding. إنزين? 1.05, which is I2, the current, times 6. Again, no confusion. This is simply V equal IR for VR5. And this is simply V equal IR for VR1. Okay? This is just VR1 and VR5. I just wrote it all in one line. Therefore, VAG is going to be 1.8 times 7 plus 11 plus 1.05 times 6, which is 29, positive 29.9 volts. Okay? That's it. That's how you'll find VAG and VCE. Any questions? No questions? Is this clear what I did here? Tamam. Let us jump into Maxwell, the last concept of the day. Maxwell شفتوا كل اللي سويتوه إذا فهمتوه. Maxwell الحين بيكون سيدة سهل عندكم. Maxwell mesh, I don't remember who was complaining a lot about it. There was someone that used to hate Maxwell for some reason. بس بصراحة, for me, Maxwell is my favorite way of solving electrical circuits as it makes my life so much easier. إنزين, week 6, which is Maxwell. Week 6. Let me actually solve the question directly. Let me see if I can find it. عشان I explain while I'm solving the question. لأن it is exactly the same concept. Okay, this is it. 1 second. إنزين. فكرة Maxwell is very similar to KVL, but it can be applied to any circuit that you have. It doesn't have to be a series circuit. إنزين. It is very similar, the concept, almost exactly the same, except that you can apply it to any circuit that has a closed loop in it, such as this circuit over here that I am going to redraw now. هني مكتوب apply Maxwell's mesh analysis to answer the following questions. وكانوا شنو questions? A lot of questions, بعدين we will look at them. Let me explain the concept first. إنزين. First things first, let me redraw the circuit. Just a small thing, by the way. The difference between this and this, okay, plus minus, يعني when it comes to application, there is no difference. In theory, this just means it's a voltage source of some type, any voltage source. This معناته specifically a battery, okay? So when they are using this, they just mean it's a DC battery voltage source. هني, when they're using this, they mean it could be AC or DC. But in your case, this is always going to be DC. So you don't have to worry about this. This is just a little extra theory for you guys later on. فعندنا الcircuit. I don't know why I'm drawing it in blue, but خلاص, since we started, we continue. We have this circuit, okay? We have a resistor here. Here I have to try to be as neat as I can عشان the concept is going to be very clear. زين. Plus minus كذي. بعدين عندنا resistor هني. Okay. So this is what it looks like. زين. Our circuit. We have R1 is 200 ohms. Actually, let me write it outside, not inside. R1 is 200 ohms. R2 is 225 ohms, which is this one. 225 ohms. And then we have R3, which is 125 ohms. We have voltage 1, which is 23 volts. This is 23 volts. And then we have 15 volts over here. Tamam? First things first, in Maxwell's, when you are assuming current, always assume that the current is, so first step, assume current clockwise. You can assume it counterclockwise, nothing wrong with it. Best, I always advise assume it to be clockwise so that you will always follow the same steps over and over no matter what. وتتعودون على التكنيك مالكم. So the current going around here for the first one is going to be different than the second one. So let's change the color. The first one is going to be orange. The second one is going to be purple. زين? So then we will call this I2. أصلا they gave it to us. They called this IB. And they called this IA. Tamam? So let's just stick with what they gave us. That's the first step we're going to do. We're going to assume the current of each one in a direction. We will always assume it clockwise. Already هني معطينا الاسsumption clockwise in the figure as well. But if it's not given, assume it clockwise. So we know that there's going to be current going through here, through here, through here, through here, through here, through here. Now, هني we know that there is current going through here, through here, through here, through here, through here, and also through here as well. If you notice the middle line, زين, both currents are interfering with it. Both currents are being a part of it. زين, and this is normal. This is exactly the point actually. This is what we want to happen so we can solve it through Maxwell. So when you're assuming a current, we're assuming the current through an entire loop. This is why they call it a mesh or a loop or analysis. لأن we are going in a full loop and coming back to where we started with the current for both sides, for the left side and for the right side. All right. So the first thing, we have to assume that current is clockwise. Second step, polarities, or I should say, identify polarities. Identify them. Okay. Identify your polarities. This way, you will not make any mistakes while solving. And how do you do this? You do it in order. So we start from here. And then a plus, minus. We are looking at this current. We are only looking at current IA now, okay? We are going to look at this. We're going to define this as plus, minus. Then plus, I don't know why I raised both, minus. The batteries are both plus, minus. The current does not affect their polarity. It's already given. بعدين هني in the middle we are going to assume the polarity of the first one, the current that we have. We can assume it to be in any direction, it doesn't matter, but always assume it in this way. It will make it will make your life so much easier with calculation. Assume plus up and minus at the bottom. This is only an assumption we are making, لأن there are two currents here. And you will see how we can identify later the polarity of it. And now for IB, this has the current is going in from here, so this is going to be plus, and this is going to be minus. And we have identified the polarities. And now we will apply the same concept that we applied for KVL. So third, KVL. Then, what does KVL state? We will look at KVL for each loop. Then, so we have this as loop A. We are going to do for loop A first. This is loop A, تمام? Which is the current IA يعني. Let us do the KVL. From minus to plus, what happens? 23 plus volts, صح? So from minus to plus, it's plus. Then we are going here, 200 ohms, so minus IA times 200 ohms. Everything we are doing like we did earlier, 200 ohms. Then we come here. هني we have a 225 ohm resistor, and it is going to be a reduction of minus 225. However, this is very important. This is the trick that you need to know. Then, when we are doing the loop here, we know that it is going to be minus. Then we know that it is going to be a drop. But we have two currents. We have IA first, and then we have IB in the opposite direction. Since we are assuming the direction of IA to be correct, so IA is our positive, then we will put minus IB. Now IB is opposing the current that we want. In other words, if you want to write this, in other words, we can also write it like this. Minus IA times 225 لأن IA is going from plus to minus, but IB is going from minus to plus. So it's going to be plus IB times 225. تمام؟ ليش؟ لأن the polarity of IB is going from minus to plus. It is a gain. It is not a drop based on our assumptions. So it is going to be plus IB 225. Either you can write it in this way, which I prefer to be honest, which is just put them in brackets, or you can directly just write them like this distributed if you understand it better. And طبعا هذا all is going to be equal to 0 as per KVL. لأن we reached back here, back to the end of the loop, to the battery, it has to all be equal to 0. Let's simplify. So 23 volts, then 23 volts minus IA and IA is, so it's going to be 200 minus 2225, so 200 and 225 minus 200, sorry, 425 IA plus 225 IB is equal to 0. طبعا, the way you will organize this is you will always put your voltage on the other side. So if we continue this, minus 425 IA plus 225 IB is equal to, we take the 23 volts to the other side, it's minus 23 volts. Okay, this is IB and this is IA. Tamam? And now we have our first equation. This is our first equation. Tamam? Our first equation is here through finding the loop, through doing the loop of IA. Now, do both currents have to be in the same direction? They do not have to be in the same direction. Actually, I'm not sure if they do or they don't have to be. ولكن always do them in the same direction. I do not remember والله من ناحية الconcept لأن I have never done them in opposite directions. المفروض it's fine because you're making the assumptions of the polarities anyways. Suppose it's supposed to be okay لأن it's just an assumption. بعدين automatically بيصحح روحه. ولكن my recommendation is always assume the currents in the same direction. I think you can actually choose them in opposite directions, but I would rather you guys just always have them as clockwise. زين. الحين خلصت for loop A. Now we are going to start for loop B. Loop B. Same thing again. I'm just going to copy paste this down here so we can look at it while solving. Loop B. We will start from the battery source. Usually I like starting from the battery source and we will go along with the current. فالحين رايحين من plus لماينس. من plus لماينس is what? It's a voltage drop. So it is going to be minus 15 volts. And the current is going opposite to the voltage source. Minus 15 volts. Yes, to answer your question, yes, you can choose them in opposite directions for sure. Then I just realized it will cancel out each other anyways. So yeah, you can choose them in opposite direction, but you will get very confused when it comes to sign and polarity, so I would not recommend you do that. المهم, back to the point, plus to minus voltage drop معناته negative 15 volts. Now we are going up. Again, the same idea here. الحين, this is a voltage gain for IB. زين, it is a voltage gain for IB. Just 1 second. Sorry about that. Okay. Now this shows it's a voltage gain for IB. However, that is wrong. لأن إحنا شو نسوي؟ إحنا we have current going through it. So this has to be a voltage drop for the right circuit. Yes, it was a voltage drop for the left, but now we are looking at it from the perspective of the right side of the circuit. ففrom the right side بيكون هني البلس and هني الماينس. تمام؟ From the right side, this will be plus here and minus here because it's a voltage drop for this one. So from perspective of IB, it will become minus 225, which is the R, times IB minus IA. Or in other words, you could say, let me just actually make this black, minus IA. Oh, you can say directly it is going to be minus 225 IB plus 225 IA. لأن now, in our perspective, IA is getting a voltage gain from the right side. Okay? So the assumption of plus minus here is for the left. The assumption of plus minus here is for the right, for the loop B. لأن we are going through it, so obviously there's going to be a voltage drop. صح ولا لا? Based on the current that we are working with. And now we continue. We have also one more resistor here, which is going to be a voltage drop, minus 125 times IB, and this will be equal to 0. Okay? Because we came back to the battery. Is it clear in the middle what happened? فهمتوا شو سويت? I will repeat. When we were doing it for the first loop, loop A, we assumed the direction to be plus minus for loop A. إنزين? Once we are done with loop A, the polarity doesn't matter because this assumption is based on loop A only. Now we are making the assumption for loop B. So we are not looking at this, we are only looking at the loop B. So the current of loop B is what matters. فحين the current is going through here, plus minus. That's going to be a voltage drop for the loop on the right side, اللي هو the current IB. Okay? Because of this, this is going to be a voltage drop, but in perspective of IA, which is the current coming in the opposite direction, it is going to be a current, a voltage gain. That is what we did, and then the remaining is just the same. Let's simplify the equation. It's going to be minus 15 volts, minus 225 and minus 125 is going to be minus 350 IB. Let me do this in black actually. Minus 15 volts minus 350 IB plus 225 IA is equal to 0. تمام؟ Okay. So now we could just simplify this equation one last time. We're going to order it the same way we ordered the first one. So IA first. So 225 IA minus 350 IB is equal to 15 volts. We just took the 15 volts to the other side. And this is our equation 2. Now, مثل ما قال حبيبنا, we have a simultaneous equation. Yes, we can use mod 5.1 for solving. أنا personally, I don't like using mod 5.1. ولكن, let me show you how we would use mod 5.1 to solve this. Let me just copy paste these two equations. Again, my advice, لأن بعدين in AC circuit, you're not going to be, you're going to have a 3x3 equation. And this is just two equations, two unknowns. إذا بتدشون AC circuit semester الجاي إن شاء الله يعني بيكون عندكم 3 equations with 3 unknowns and you're going to have to do the full matrix by hand. Okay? So enjoy. The way you will do this in the calculator using mod 5.1, then mod 5.1, you can solve this as solving any simultaneous equation. And I would use linear algebra because that's my preferred method, which is mod 5.1 does the exact same thing. ففي الكالكوليتر بيطلع لكم شيء كذي. اذا سويتوا مود 51 يطلع لكم 2 tables. زين، بيستوي هني مكتوب هذا فوقه A، هني B، هني C. زين، وكله بيكون مكتوب فيهم zeros. فانتوا شو بتسوون؟ you're gonna put the minus 425 here, you're gonna put the 225 here, and you're gonna put the minus 23 here, and you will do the exact same thing. This is for the first equation. Okay, you will do the exact same thing for the second equation. You will put this value here, الازرق the 225 بتحطونه هني. minus 350, remember the signs, you're going to put it here, and the last one, which is 15 volts, you're going to put it in your C value. How will I write this in the calculator? First one is going to be minus 425, that's my first one. Second one will be 225. Third one will be minus 23. Yes, including signs. Always include signs in calculations. بعدين بروح للسكند row, 225 minus 350 15 equal, بيطلع لي x، الجواب بيطلع لي x is equal to 0.0476 ampere. بس بعدين I will show you. And then you hit equal again, you will get y is equal to minus 0.0122. زين، 223. okay. first one، زين، لو تلاحظون equation 1 x value it will be the first value you selected in the beginning, which is the I value, the IA value. Oops, I should not highlight it. I should just circle it. زين. this is going to be your x, IA. And the second value is going to be the second order. يعني تشوفون هني the first one you put in the order is going to be your x value. The second one you put in order, in this case it is IB. This is going to be your IB value. This is your second one that you put. So this is IB. فحلينا IA is equal to plus 0.0476 amperes, and IB is equal to minus 0.01223 amperes. All this minus means that we assumed the wrong direction. So if I copy paste this again, then if I copy paste this again, الحين we know the actual direction of IB should be the opposite way, because we know that IA now is how much? 0.048 amperes, and we know that IB is in the opposite direction. يعني we assumed the incorrect direction, which is fine لأن الجواب طلع لنا كماينس. So now we know that the current IB has to flow in this direction. So this will fix all our polarity issues as well now, and we will be able to solve everything correctly. So it's 0.012. okay. الحين the most important thing I want to tell you guys is خليني أخلص هني أول. So this is like this, this is like this, this is like this, like this. الحين هني بعد it's in the same direction. Okay. So polarity is correct. The assumption, the first assumption of polarity here is correct. Here it was the opposite. لأن it has to be where current is going in. So the correct polarity is going to be like this, plus minus. Okay. The middle polarity is correct. How can we find the current going through the middle resistor now? We are going to add both of these currents. They're both in the same direction. If they were in opposite directions, we were going to subtract. So in this case, this was called R3, صح? IR2, the current that is going through R2 is going to be equal to IA minus IB سابقا قبل ما نحط غير شو اسمه اليونت. زين. So IR2 is equal to IA minus IB. It will become 0. كم كان 0.476 minus 0.0123, which makes sense. لا لأن الحين when we fix the direction we realize that we are adding these two. the answer is always going to be, the IR2 is always going to be the opposite. It's always going to be like this when you assume your directions to be clockwise. And if you assume both of them to be clockwise, your I in the middle is always going to be this minus this. Always. Always. Tamam? So this is going to be equal to 0.0476 plus 0.0122. It's not 123, it's 122. Then, and then you're just going to add these in the calculator, and you're going to have your final current that is going IR2, that is going through R2. IR2 is equal to plus 0.0122. 0.0598. All right. So this is the amount of current you have going through the middle. فإذا نبغى احنا نكتبها بالأحمر أو بالأخضر مثلا، زين. So if this current is in green, okay, this is going to be removed here, here, and here, and here. And this current over here is going to be our green current. بس. And this is how you apply Maxwell's mesh loop analysis to anything. I hope this was clear. Sorry شوي طولت عليكم. If anyone has any questions, you can go ahead, including يعني لازم في النهاية نكتب clockwise وانتي clockwise صح؟ لا في النهاية ما بتكتب clockwise anti clockwise. Well, yes, يعني قصدك من ناحية current, yes, you can write that and then if you want, but when you write it negative and you already assumed clockwise, that is enough, so there is no issue. يمدي أكتب في الأخير من البداية إن sum of two currents IR2. لا لأن it is not the sum of both currents. هو على حسب الassumption you made from the very beginning. إحنا هني IA we assumed it to be going into this direction and IB is going in the opposite direction. فإحنا we assumed إن IR2 is voltage drop IA minus IB. That is what we assumed from the very beginning. فهمت؟ لأن we assumed that the current going through here. إنزين. Another way of looking at this, if you want to look at this in another way, from the first circuit, if this is confusing. Actually, I don't want all of this. I just want to focus on the middle part. This is our circuit that we have. Okay, let's not look at all of this. Let's not look at all of this. I just want you guys to focus on this joint over here. This joint over here. هني we know that any current going in, okay, this is kind of KCL. We know that this is the point. معناته هني لازم يكون في current going this way, okay? Or it's going the opposite way. You can assume it in any way you want. فرضاً, let's assume it that it's this way. Let's call this IA, this IB, and this is I don't know, IR, okay? لازم everything that is going in is equal to everything that is going out. In other words, IA has to be equal to IB plus IC IR sorry اللي هو IR تحت هني. لازم لأن any current going in has to be equal to the current going out, and this is an assumption we are making. This is just an assumption we are making that the direction is downwards. Okay, إذا طلع ال IR مالنا negative معناته our assumption is wrong and it is upwards. Again, there's nothing wrong with making assumptions, just understand what they mean. فif I rewrite this equation to find IR is simply equal to IA minus IB. This is what this means. This is what this IA minus IB means, okay? So you can either understand it through the voltage drop concept, or you can understand it through this node concept where if currents are going in, it has to be equal to all the currents that are going out.